welcome to today's class. For today's class, we're looking at Lewis dot and dash formula. By definition, Lewis dot and dash formula is simply a formula using dots or dashes to represent valence electrons. Alright, so when it comes to Lewis dot and dash structure, we simply use dots or dashes, as the case may be, to represent valence electron. So when exactly do we use dots and when exactly do we use dashes? For us to understand this concept, let's look at what is called lone and bonding pair. Let's consider lone and bonding pair. Alright, in simple terms, a bonding pair is simply a pair of valence electrons that is shared between two atoms during a combination process. That's a bonding pair. While a lone pair is simply a pair of electrons that is not shared between atoms during a bonding process. So that's it. One thing to note is that for bonding pair, they are represented by dashes, while lone pair are just represented by dots. Alright, so we use these two concepts to learn how to write Lewis dot or dash formula for compounds. So what you should notice is this: a bonding pair is simply a pair of electrons that is shared between atoms during a combination process, while lone pair are simply pairs of electrons that is not shared between atoms during a bonding process. It's that easy. Now, one thing for you to notice is this. So, note that lone pairs are represented by dots. So, this is a pair of electrons, or perhaps maybe in this form, depending. So, lone pairs are represented by dots, while bonding pairs are represented by dashes. Alright? So here's what to note. Lone pairs represented by dots, bonding pairs are represented by dashes. We'll take some few examples and see how we can write Lewis structure or Lewis formula for different compounds. Let's start with a simple compound. Let's say a hydrogen molecule. Let's start with hydrogen molecule. So let's say that you write the Lewis structure for hydrogen molecule. Of course, a molecule of hydrogen is diatomic, so I'm having H2. So for this, what do I do? My first task here is to get this signifies that I have two hydrogen atoms combining. That's H plus H combined to give H2. Now before this, I need my valence electrons. For hydrogen, I have just one valence electron. We discussed valence electron in our previous class. So hydrogen has just one valence electron each. Now when these two combine, it combines to give you this hydrogen. So these two will combine to give you this and this. Then you have H. So I have this one here. In this case, both atoms are stable because they have duplet configuration. So that has 2 valence electron. This has 2 valence electron. Now if I look at this now, this pair, is it a bonding pair or a lone pair? We said for lone pair, they are not shared between the atoms combining, while for bonding pairs, they are shared between the atoms combining. These electrons are being shared by these two, so that each of them can obtain duplet configuration. So hence, I will change this from 2 dots to 1 dash. Alright, so this becomes the Lewis dot or perhaps dash structure for hydrogen molecule. Let's look at yet another example. For next example, let's look at the formation of ammonia. Ammonia, by the way, is and H3. So look at the formation and see how to write the Lewis dot or dash structure for ammonia. So first things first. Let's say I choose to write the chemical reaction of the equation leading to the formation of ammonia. From this, it means 3 atoms of hydrogen. Now, hydrogen itself is diatomic. Combined with nitrogen itself is also diatomic. Will combine to form NH3. My next task will be to balance this. To balance this equation here, of course, nitrogen has 2 here, so I'll apply 2. This gives you 2 nitrogen. Hydrogen becomes 6. You can see 2 times 3 gives you 6 atoms of hydrogen. The hydrogen here is just 2, it's not balanced. So I'll have to add 3 here. So this now balances the whole equation. So in total, I have 6 atoms of hydrogen, 2 atoms of nitrogen on the left hand side. On my right hand side, I have 2 times 1, 2 atoms of nitrogen, and 2 times 3, 6 atoms of hydrogen. So let's get this done. So if I'm having 3 atoms of hydrogen, I'll simply get the valence electron for each of them. For this, it becomes hydrogen, I have 1. Hydrogen, I have the second one. Hydrogen, I have the third one. These are the 3 atoms of hydrogen that will combine with nitrogen. My first task is to get 1 atom of nitrogen. Alright? So 1 atom of nitrogen here. So plus nitrogen is atomic number 7. So the combination becomes 2, 5. So nitrogen will have 5 valence electrons. 1, 2, 3, 4, and 5. From here now, if I combine this one goes up here. So I'm having nitrogen here. This up here I have 1 dot. Okay. Then I have hydrogen. Coming this way here, becomes hydrogen with its 1 dot, becomes hydrogen with 1 dot. Okay. Next up, nitrogen to my right, I have 2 dots. I'm having 1, 2. Okay. Nitrogen downwards, I have 1 dot. So you have just 1 dot. Combining with the hydrogen below it, that's 1 dot. So it becomes H. And then dots. Finally, nitrogen to my left. To the left this way, I have 1 dot. That's this one here. Combining with hydrogen, coming with its own 1 dot. I have 1 dot. So I have this. So this becomes a combination. From this one here, my task is to differentiate between lone pairs and bonding pair. These 2 are lone pairs because it is not shared between any atom. Is just a nitrogen. These 2 are bonding pairs because it connects hydrogen and nitrogen. So we'll combine this to a dash. So I have a dash here. Next up, these 2 are bonding pairs because they connect hydrogen and nitrogen. So it becomes a dash. These 2 are also bonding pairs because they connect nitrogen and hydrogen. So I have these 2. So that means the Lewis structure becomes nitrogen, 1 dash upwards to hydrogen, 1 dash to the left to hydrogen, 1 dash downward to hydrogen, and then you have double lone pairs. I have this. So that means in ammonia I have 1, 2, 3, 3 bonding pairs. Ammonia has 3 bonding and 1 lone pair. So please note that ammonia has 3 bonding and 1 lone pair. While hydrogen molecule has 1 bonding and 0 lone pair. Alright, So this is like a simple idea of how we write the Lewis dot and dash structures or formulas of different molecules and compounds. Let's look at it in a broader way, in a broader concept. How do we present the writing of Lewis dot and dash structure in case of examination? So let's look at it. Alright, so let's look at writing Lewis dot and dash formula in a broader perspective. Now, to write Lewis dot or dash formula, note the following. Number one, so your steps. Number one, calculate the number of valence electrons. That's the first step. Number two, write the skeleton or skeletal structure of the molecule or ion connecting every pair using dots for lone pair or dashes for bonding pair. That's what you have there. Alright, let's take an example. Example, sulfur dichloride SCl2 is a red fuming liquid used in the manufacture of insecticides. Write the Lewis formula for the molecule. Alright, write the Lewis formula for the molecule. Alright, so let's get this done. So we're given SCl2 as sulfur dichloride molecule. We are asked to write the Lewis dot, we have dash formula of this molecule. So what do? We say step one involves calculating the total number of valence electrons. So for this total number of valence electrons for sulfur is atomic number 16. So the configuration becomes 2, 8, 6 using the differential. So the valence electron is 6. So sulfur has 6 valence electrons. Chlorine is atomic number 17. Alright, sulfur is atomic number 16. 286 has 6 valence electrons. Chlorine is atomic number 17. The KLMN shell configuration becomes 287. Hence, it has 7 valence electrons. So I have this. So here's my first task. Calculate number of valence electrons. So if this is true, the number of valence electrons is equal to, I have one sulfur atom, that becomes 6, plus I have 2 atoms of chlorine, so it becomes 2 times the number of valence electrons for chlorine, 2 times 7. So this is the pattern of how you solve this. So it's equal to, so I'm having 6 plus 2 times 7 is 14. That's equal to 20 E minus. Please, the E minus means electrons, alright? 20 E minus, so I have 20 electrons in total. Let's get this done. When it comes to writing Lewis structure, it depends on how you want to position this. For this, I can see that sulfur atom is attached to 2 atoms of chlorine. So that means I could choose to put this as sulfur, chlorine, this way, or perhaps sulfur, chlorine. So either position them horizontally like this or vertically like this, whichever way it is correct. For this question, I am choosing to position them horizontally like this. So that would mean I have sulfur somewhere at the center, having how many? 6 valence electrons. Yes. 1, 2, 3. Can we make this bigger? That gives you sulfur having 6. So 1, 2, okay, 6. So I'm having this. So this is sulfur. I have chlorine, Cl. I have chlorine, Cl. So I have sulfur, chlorine, and chlorine. Now, how do I write this? Your idea will now be this. So I have sulfur this way, I have chlorine, I have fluorine. So how do I position this? The idea with this, I know fully well that chlorine is has a valence selection of 7. So what I will do is I will position 1, 2, 3, 4, 5, 6, 7. Now see why I position this, such that this one can easily combine with 1 from sulfur to make this octet, that's 8 configuration. That's simple. Also the same idea comes here, so it becomes 1, 2, 3, 4, 5, 6, 7. So it's very important that you draft out the pattern before you start making your dots, so you don't make mistakes. Alright, for sulfur, this is 7 valence electron, this is 7. They both need 1, 1 to make them 8 and 8. So what's the idea here? I'll just simply place 1 here from sulfur, same thing, 1 from sulfur, and then this is 1, 2. Sulfur has 6 valence electron. I've written 2, remaining 4. So I'll just put 1, 2, 3, 4. This combined. So I'm having this combining to form the sulfur dichloride. So instead we have 20 electrons. If you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this, the number of dots matches my 20 electrons. Alright, proceeding with this. So this now gives you, take off the plus, I have chlorine having dots and dots to solve for these two. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. So I have dots, dots. 1, 2, 3, 4. 1, 2, 3, 4. Chlorine, that's Cl. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright. So we are now here. Final task. Separate lone pairs from bonding pair. So with this, these two are bonding pairs because they connect chlorine and sulfur. So this becomes a dash. These two are bonding pairs because they connect sulfur and chlorine. It becomes a dash. This one is not connecting anyone here. So 1, 2, 3, 4, 5, 6, 7, 8 are called lone pairs. So hence, the Lewis structure for sulfur dichloride becomes S, a dash to chlorine, another dash to chlorine. So I'm having 1, 2, that's 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, these two here. These two here, that's 1, 2, and these two here, so I have 1, 2. So in total I have 1, 2 bonding pairs, 2 bonding pairs, and I have these two form a pair. So this is a pair, 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair, 7 pair, 8 pair, and then 8 lone pairs. This is how you present your work in terms of an examination. So this is how we find the Lewis dot dash structures for molecules. So let's look at yet another example on this. It says dichlorofluoromethane, CCl2. So CCl2, F2 is a gas used as a refrigerant and aerosol propellant. Write the Lewis formula for dichlorofluoromethane. Alright, so let's get this done. Alright, so solution. My first task is to get total number of valence electrons. Total number of valence carbon is atomic number 6. So the configuration becomes 2, 4. So it has 4 valence electrons. Chlorine is atomic number 17. So the configuration becomes 2, 8, 7. And that's about 7 valence electrons. Fluorine is atomic number 9. The configuration becomes 2, 7 to give you 9. So this becomes 7 valence electrons. So I have this one here. Alright. So next up, let's get the number of valence electrons. So it becomes, for carbon, just one atom. So it becomes 4 plus, for chlorine, 7 valence electrons times, but we have 2 atoms. So times 2 plus, for fluorine, it has 7 valence electrons times 2. So in total I have this is 4 plus 7 times 2 is 14 plus 7 times 2 is 14. If I combine this gives you 28. 28 times plus 28 plus this. So this 4 plus 14 gives you 18. 18 plus 14 gives you 32. So I have 32 valence electron in total. Next up, number 2, you said write the skeletal structure. So number 2, for skeletal structure, we have. So again, before you draw your structure, you make an inference. We have 2 chlorine, 2 fluorine, 2 carbon. So how do you want to draw your structure? You can either draw it as carbon at the center, chlorine here, fluorine, fluorine. So it becomes 2 fluorine, 2 fluorine. Or perhaps you can swap the position and bring it here as fluorine, 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 fluorine. For whichever case, you know that carbon should be at the center. So most of you should be sure to get this sketch first. So it gives you an idea of how you're drawing your diagram. Okay. So I have carbon here. So carbon here. Carbon combines with, I have, we said one carbon combines with the number of valence electrons for carbon 4. 1, 2, 3, 4. So I'm just going to put perhaps chlorine at the horizontal side. So it becomes chlorine. So plus chlorine, I have 1, 2, 3, 4, 5, 6, 7. Okay? Put chlorine here. See that I have 1, 2, 3, 4, 5, 6, 7. Put fluorine downwards. I have plus F. I have 1, 2, 3, 4, 5, 6, 7. And then fluorine downwards. F. I have 1, 2, 3, 4, 5, 6, 7. So I have this one here. Alright. So if I look into it, I have 1, 2, 3, 4, 5, 6, 7. Okay. 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So it tallies with 32 valence electrons in total. So this will now give, carbon at the center. Just going straight to the final answer. These two will form a bonding pair. That will now become a dash. So dash to chlorine. These two will form a bonding pair and becomes a dash to fluorine. These two will form a bonding pair that becomes dash to chlorine. These two will form a bonding pair that becomes dash to fluorine. So I have this. If you observe, chlorine becomes 1, 2, 3, 4. It's combining with this, becomes 5. Also with this, that's 6. Also with this one here, 7. Also with this, 8. So chlorine, carbon has achieved the octet configuration. It's now stable. For all of them have now achieved octet configuration by combining. Chlorine becomes 1, 2, 3, 4, 5, 6, 7, 8. Fluorine, same thing, 1, 2, 3, 4, 5, 6, 7, 8. Same thing with this and this, they all combine to give you octet. So I can now proceed. So from here, after getting the bonding pairs, this, impute their lone pairs. This one has 1, 2, 3, 4, 5, 6 as a lone pair. So 1, 2, 3, 4, 5, 6. Chlorine has 1, 2, 3, 4, 5, 6 as lone pairs. It becomes 1, 2, 3, 4, 5, 6. This chlorine also has 1, 2, 3, 4, 5, 6 as lone pairs. So 1, 2, 3, 4, 5, 6. And finally, fluorine here has 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, and 6. So I have this. Alright, so with this one here, we've gotten the Lewis dot or that structure for dichlorofluoromethane. It's dichlorofluoromethane. Alright, dichlorofluoromethane. So this becomes the Lewis structure. So how many bonding pairs do we have? How many lone pairs? For bonding pairs, we have 1, 2, 3, 4. So 4 bonding pairs. How many lone pairs? These two form in pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 lone pairs. Alright, so this is how we write the basic type of Lewis structure for different formulas and molecules.